Well, good day, everyone. This is Chris back again with the Ancient Scholar. So I'm going to pick up where I left off on the last video. The second video I kind of left off, and I'd said that metals like to give up or like to share electrons, or not share, but they actually like to get rid of their electrons. And nonmetals like to take electrons. So metals give them up, and nonmetals take electrons. And there is a certain property of atoms, very special property, helps us predict things like certain types of chemical bonding, certain types of molecular geometry. It helps us predict if a molecule is going to be polar or not. If you don't know what that is, you definitely will learn about it later on. But it's a very important property, and that property is known as electronegativity. So let me just write that down here. Electronegativity. And I hope I spelled that right, but it's electronegativity. Okay. What is electronegativity? Well, electronegativity is really how, in basic terms, it's how badly does an atom want to get a hold of an electron. Okay, that's basically what electronegativity is. How badly does a certain atom want to get a hold, or how badly does it attract electrons? Attract electrons. That's electronegativity. So we said that metals like to give up electrons. So if we go off of what we know of metals, they like to give up electrons. Would we think that they're very electronegative? And the answer is no, they're not very electronegative at all, because they'd rather get rid of their electrons. So I have a little periodic table here, but you can see it looks a little different than you may be used to seeing. And I pulled this off of the internet. This is called the Internet Dictionary of Science. This is a picture that I pulled off of there to kind of reference that. And this actually gives the electronegativity of each element. And this is actually, there's a number. You can see hydrogen has a 2.1, lithium has a 1.0, fluorine has a 4.0. These are very common. These are kind of a semi-quantitative way of looking at electronegativity, and these are known as Pauling numbers. Pauling with a G, Pauling numbers. Of course, named after Linus Pauling, a very famous Nobel laureate and chemist. Very high numbers are high electronegativity, very low numbers are very low electronegativity. So the basic trend that we see with electronegativity is electronegativity increases as we move to the right. Okay, and that should come as no surprise, because we're moving from metals over here, right? These are all metals with the exception of hydrogen. And of course we know metals have very low electronegativity, and if we're moving to the right, then we're moving toward the nonmetals, which are more electronegative in general. Electronegativity increases as we move to the right, and it also increases as we move up on the periodic table. So it generally increases as we move right and up, and that is the general trend. This is known as a periodic trend, and this is one of the very important periodic trends that is at least qualitatively predicted by the periodic table of elements. So periodic trend. electronegativity happens to be one of the many periodic trends that we run into, one of the very important ones. Okay, so as we can see here, the nonmetals are highly electronegative, and actually the most electronegative elements are actually these little three guys here: nitrogen, oxygen, fluorine, and then chlorine. Fluorine is the most electronegative element. It's highly electronegative, highly reactive because it likes to get a hold of those electrons. Oxygen is next in line, and then nitrogen and chlorine are kind of tied there. So again, when we talk about electronegativity, or the ability to attract electrons, electronegativity increases as I move right and up on the periodic table of elements. Likewise, electronegativity will decrease as I move left, because I'm moving toward the metals, and metals, as a general rule, are not as electronegative. As I move to the left and down, my electronegativity decreases. And this is very obvious when we look at our group 1 elements over here: lithium, sodium, potassium, and so on. They really want to get rid of their electrons to meet their octet rule, whereas we go all the way over here with our group 7s, they really would like to get a hold of electrons. And of course, our noble gases over here really don't have any electronegativity. Their octet rule is met, they're stable, they're not chemically active, so we don't really include them. So that was just a basic introduction to the one of the periodic trends known as electronegativity. As always, thanks for hanging in there, guys.